Designing and implementing stored procedures. I love stored procedures. Can you tell? They are awesome and they come with a lot of benefits from a lot of different angles. Management benefits, security benefits, performance benefits, and people allowing people like developers and anybody that wants to use our database an easy way to interface with our database and the data within them. So in this nugget, we're going to take a good look at how to design and implement stored procedures. We'll start here with just a quick overview to talk about what stored procedures are, the different things we can do with them, their structures, parameters, return values. We'll talk about all the benefits that we get from them, and then more importantly, we'll talk about how to properly design stored procedures and some things to think about when you design them. From there, we will jump into the virtual Nugget Lab and take lots of demos here on how to design and implement stored procedures, starting with the basics. We'll create a simple stored procedure with an input parameter. We'll execute it so we can see the results that come back, and then we'll really take it to the next level and see how to design for data access. We'll create a single stored procedure that we can use many ways, and here we'll also talk about the parameter sniffing problem and execution plans and really how to design around optional parameters so we don't hurt performance. From there, we're going to break out .NET and C# and build our own CLR stored procedure. So we'll create a DLL in assembly. We'll, again, register it inside of SQL Server. We'll create a stored procedure on top of it, and we'll see how that process works. And we'll finish it up here with how to work with table-valued parameters. So if you want to pass a whole table to your stored procedure, we're going to need to create a table value user-defined type that we can then create, fill, and pass to our stored procedures. Let's start with an overview of stored procedures. What is a stored procedure? Just think of it as a bunch of transact SQL stored on the server with a name attached to it. So anytime we want to execute that group of transact SQL, we just call it by name. And then optionally pass parameters to it. Parameters will change the results that come back. When we execute a stored procedure, we will get results. Results could be rows. It could be an output parameter or a return value. Rows is going to be the most common ones. Execute a stored procedure, get some data back. We can also, though, return an output parameter if we wanted to maybe generate an ID and then send that ID back because maybe a developer needs that ID for the data they just inputted. Or we could do a return value, which generally we're only going to do for status codes or error codes. We generally use stored procedures to provide a data access layer to all of our data validation, or encapsulating business logic. So we're going to use it here in this nugget to do data access. We'll create a search engine on top of our data that can be used many ways by many different people, developers or business analysts or anybody that has access to them. The kind of stored procedures we have in SQL Server, we have system stored procedures. You can identify them with an SP underscore. One of the reasons we should never name our user-defined stored procedures with an SP underscore. But these are generally going to be used by administrators to configure things like servers, databases, objects, or even just get information about them. Extended stored procedures just extend the functionality of SQL Server. We used one in a previous nugget when we got disk drive information to get the drives and the amount of free space available. So you'll see a lot of extended stored procedures to do things like that. You can identify these with an XP underscore. And then user-defined stored procedures, the ones that we're going to create. And a best practice is to always name your stored procedures with some kind of identifier relating to what you're doing. Especially useful in those multi-purpose databases where you have a lot of applications that use the data. If everybody just named their stored procedures whatever, then it would be hard finding them. If you prefix them with something like the application that they're associated with, then it's much easier to find them and manage. Oh, and it's also worth noting that CLR stored procedures will eventually overtake extended stored procedures. Some of the benefits of stored procedures. Modular programming is a big one. We can encapsulate all of our transact SQL into this named object and then call it many times, many different ways. And we're going to take a good look at how to do that in the virtual Nugget Lab. Another one is enhanced security. And there's actually two sides to this. The first one is enhanced security management because we don't have to give users or anybody access to the underlying objects inside of a stored procedure. We can just give them access to execute the stored procedure, and that's it. We don't have to give them access to the underlying tables or views or whatever the stored procedure touches. The other side of this is it's a great frontline defense against SQL injection attacks. So we've got multiple security benefits. Also centralized administration. It gives us a nice centralized point, again, of managing permissions. And then two big ones here, performance. Performance, as I wrote there, that should say performance. A couple of performance benefits. One is reduced network traffic. Rather than having developers submit big honkin' dynamic SQL to our server, which is also a security risk, they can just call a stored procedure by passing in the procedure name and then optionally some parameters. much, much less network traffic out there. And another one is execution plan caching. Anytime you execute a stored procedure, SQL Server is going to create a plan and then cache it so any subsequent executions can reuse that plan and we can get a big performance benefit out of it. As far as some design guidelines go, we should always qualify our object names within our stored procedures. And also, when you execute your stored procedures, you should qualify it with schema.storedProcedureName. That way, SQL Server doesn't have to guess where it is. Because if you don't, if you just execute it or you just use just the name of the object itself, then SQL will find it. It'll find it eventually, but it has to look. It has a list that it goes through to look for where these objects exist. So you can give a small performance boost by ensuring that you always qualify your object names. Also use consistent naming conventions, as we looked at over here with our naming. The benefit of doing that makes it easier to manage and find things. Understand parameter sniffing. So parameter sniffing goes along with plan caching. And how this works is, let's say that I have a stored procedure that I execute with a certain set of parameters. And then I execute it again, only the parameters have changed. Well, that could actually hurt performance because it's going to use an execution plan that isn't optimal. So generally, execution plan caching is a good thing. I mean, most of the time it's going to be a good thing. But when you create a stored procedure that's multi-purpose, that may have different parameters and different values for parameters, then you could actually hurt performance. So we're going to get a good example of this, as I mentioned, when we get into the virtual Nugget Lab, on really how to prevent this. But essentially what you'll want to do with stored procedures that have different uses is make sure they recompile, either at the procedure level or the statement level. And I'll show you how to do both of those. But just keep in mind that the general thing to take away from this is, yes, execution plan caching is very good. But in those cases where your parameters may change often and the results of the stored procedures are going to be very different, then you'll want to force a recompile of the stored procedure, because you'll get a better performance gain out of using a brand new execution plan and recompiling the stored procedure than you would off using an old execution plan that doesn't really match with the caller's intent. And finally here, encrypt your stored procedures when necessary. If you have sensitive stored procedures or code within them or objects within them, then it's a good idea to obfuscate it so nobody can get at the definition. And we'll look at how to do that as well. With that, let's make our way over to the virtual Nugget Lab and learn how to design and build stored procedures. All right, so we're in the virtual Nugget Lab. Let's bring up Management Studio. We've got a new project, 10.stored procedures, and we're going to start here with the basics, creating and altering stored procedures. So the first thing we're going to do here is just create a basic stored procedure that's going to get the trainer's profile. So we're going to take an input parameter here as trainer ID. That way, anytime we call the stored procedure, we're going to pass in a trainer ID, and that will get us that trainer's profile. This is a required parameter. If we wanted to make it optional, we could do that. And then we can, as we'll see going forward here, how to manage and deal with null values inside of our stored procedures. But essentially, all we're going to do here is select everything that we need, trainer ID, name, expertise, the photo, from our trainer, where that trainer ID in this table equals the input parameter coming in. So basic stored procedure, right? And I should also mention here this photo. I did load up a couple of photos into our trainer table, and this little case statement here just says if it's null, then it's going to grab this default logo as the trainer photo. If not, it's going to return the actual photo itself. So let's do this. Let's create this stored procedure inside of the Nugget Demo DB, and then we will see how to call it. How to call it is pretty simple. We can just do an execute or an exec. Name of the stored procedure, CBT underscore, get trainer profile, there it is, and pass in a trainer. Here we go, we'll pass in me. And there I am. Cool, right? That's pretty easy. Now, we could call this many ways using whatever trainer ID we want, and we will get that trainer's information. So that's just a really simple example of how to create a stored procedure to encapsulate some logic that we can then call with different parameters and reuse the logic, but get different results. And you can see we use some best practices here. We prefixed our stored procedure with CBT underscore, so we know this is a core stored procedure. Since we have a CBT Nugget database, we could call that core. And now if we had any other applications that integrated with it, those stored procedures could be prefixed with that application's name. So we have clear separation between our stored procedure, what belongs with what inside of our database. It won't look so cluttered, and it'll be a lot easier to manage. So this would make it really easy for somebody like a developer to build a application around, because they can interface with our data through this stored procedure. In fact, just to give you the big picture here, because I love doing this stuff, I whipped up a little C# project, a WinForm project, that uses that stored procedure. So here it is. It is the SQL Trainer Profile project here. We're going to get into this other project when we get into CLR stored procedures, but I just whipped up a little WinForm that calls that stored procedure. And let me show you what this looks like. So here it is. So the first thing it does is it just runs a straight query against the trainers table to get a list of trainers. And then anytime you click on a trainer, it executes that stored procedure, extracts the name, the photo, and the expertise and throws it in here. Cool, right? And if it can't find, if I don't have an image for somebody, it defaults by reading that image, that default image off of the hard drive and putting it inside of the picture box here. So cool. I thought this would be a fun one to include because it does kind of give the big picture of how to call these stored procedures from outside a SQL Server. So that was it. And obviously the source here will be included with the course, so you can take a look at how that works. But just to show you real quick, I don't want to get deep into the code or anything here. If we were to click on that item in the list, it would call this load trainer info, which is right here. And there it is. There's a call to our stored procedure, passes in the trainer ID, and then just binds it all to the form. That's it. There's really not a lot of code for that entire application. Cool. So we'll come back to this when we get into SQL CLR. Let's move on here and look at how to really design a stored procedure for data access. So let me set the stage for you. Let's say that you are a developer at CBT Nuggets, and your bosses, Ryan and Dan, come in, and they say, hey, ma'am or sir, I need you to build me a single stored procedure on top of all of our course data so we can use this one stored procedure across all of our tools, our front-end website, our internal tools for searching courses. And you're like, all right, I can do that. And then they say, oh, wait, we don't even know what our requirements are. we want course ID searchable, course title searchable, course description searchable. And if we pass in course ID, we want that specific course. If we don't, we want all courses. If we pass in a title, we want that title. If we pass in part of a title, we want everything with that title. So we want one stored procedure to handle the search engine to everything courses. And you're like, oh, okay, I can do that, but it's going to cost you. I get all of next week off. Just kidding. Don't try to haggle with your bosses. It generally won't end well for you. But okay, so let's do this. So we're going to build a really simple stored procedure to do that. We're going to create two input parameters. We're going to nullify both of them so we make them optional parameters, and we will have to put special code in to make that happen, because if we create this, let's do it. Let's create this stored procedure and then call it. You would think calling it without any parameters means we would get all of the courses. That's what was described to us in the requirements. So if we execute this, we get no courses. And again, that's because nulls do not play nicely with our where clause. So we need to have a special case for that. What if we just try to pass in the course title and not the description, meaning it'll be an actual value for title and null for course name? Same thing, because we have an and on it, and that is going to ruin it. Maybe if we switch this to an or, it would work, and we could alter this here. And let's do that and try it with an or. Now it should work because we got an or on there. So we will get everything that has SQL in it and the title. But what about both? Again, that'll work with an or, but it still won't work by all course names. See that? So this is bad design because we can't get to where we want to go. Let's look at the right way to do this. And this time we'll do what the requirements suggest, and that is course ID. We're going to add course ID onto it. So this stored procedure is going to allow us to search by nothing. We could just call the stored procedure by itself and get all the courses. We could pass a course ID, get a specific course. We can pass a mix match of title and description or course ID, anything we wanted to get the results that we want. So here's the trick. The trick is, in your where clause, we need to do a Boolean check. We're going to do a course ID is null or course ID equals the course ID. What this will do is, if our parameter is null, it'll be completely ignored, and that's what we want. So this is the exact way to do optional parameters right here. And on top of that, I'm going to talk about this option recompile down here. Let's just first create this without that, hit execute, and let's look at how many ways we can call this stored procedure. Now look, we can call by getting all courses. Yeah, look at that, we get all the courses. We can call by getting a specific course, which is good for developers there, right? Anytime someone wants to edit a course, they can go into that course, and then when they click the save button, it'll pass the ID and all the updated data, and it'll do it. So obviously we would need to create a CBT update course for that one to work, but here we go. Here's course ID number 42. We can search a course by name. There it is. There's everything with SQL in it. We can search a course by just description. There's everything Microsoft in it, or we can do both name and description. We'll get courses that have SQL in both the name and the description. There it is. So this is just a great way to design your data access layer because we can have one stored procedure that handles everything for a specific entity, and now many developers or types of applications can use this one thing multiple ways. Now there is one little hitch here, one little gotcha when it comes to optional parameters, and that is query plans. Now query plans, execution plans are usually always going to be a good thing. Anytime you execute, say, a stored procedure, it's going to cache the plan and the parameters and the values associated with them. So the next time a call comes in, it can reuse that plan without having to build a new one, which gives us a nice performance boost, especially if you have a website where you have lots of queries going on every second. Then you can get a big performance boost by reusing similar queries with similar parameters. Now here, because our parameter values are going to change, we have so many different ways to call the stored procedure, query plans can actually hurt because SQL Server will reuse that query plan that may be the wrong plan, or a plan that was good for this one is not going to be good for this call. So that's why we want to force recompilation of this stored procedure, and we can do it at the statement level or we can do it at the stored procedure level. Here we're just going to do it at the statement level with an option recompile. But really to first see this, let me show you how it looks. So let's just run the stored procedure. Let's turn on include actual execution plan. That way we can actually see it. And now let's execute all 5 of these stored procedures. So what you're going to see here, if we look at the execution plan, is 20%. Each query, each stored procedure execution took the exact same plan. And you can see that because the cost related to the batch is 20% across the board. That tells us that it used the same plan for everyone. And that's bad. That actually hurt performance. Now watch this. Let's put our recompile on. We're forcing a recompile this statement. Every time this stored procedure is executed, the query engine is going to make a new query plan. And while you think that might be a bad thing for performance because it has to recompile the stored procedure every execution, in this case, it's going to be very, very good for our stored procedure. So let's do that again. Execution plan is turned on. Let's look at it. Look at this. So 33%. And this was the first query was the one that grabbed them all. So that should have taken the longest because it returned the most data. The second one we searched by ID. Look at that. That's more like it. 7%. If we scroll down here, 19% for searching by the name, searching by description and name 30%, and then the last one here where we searched by, the last one was description and name. It took 12%. So this is what you want to see because now we get more, a better performance out of each individual query. So that's why it's important to understand parameter sniffing. That whole thing is called parameter sniffing, where it creates execution plans and reuses them based on the parameters going in. So just be aware if you start designing stored procedures that are multi-purpose and that have dynamic parameters and optional parameters coming in, that you will want to force recompiles on them. Let me show you one more here, and this time we're going to add a course. Let's create a stored procedure that inserts a brand new course. So we're going to create it the same way we did, have a bunch of input parameters here, but our last parameter is going to be an output parameter. So let's say whenever we create a course in a front end, we're going to want to pass back to the developer the ID that was generated, the identity value that was generated, so they can then use it on the front end if they wish to. We're also going to do with encryption. So this will be an encrypted stored procedure, meaning no one will be able to see the insides. They won't be able to modify the stored procedure and look at the code. We're obfuscating the definition of the stored procedure. So this is just a simple insert statement, taking the input parameters and tossing them right into the values portion of the insert clause here, the insert statement. But the last thing we're doing is we're going to fill in this output parameter with a course ID using the entity global variable, which is going to contain the last inserted auto number based on our connection here. So this will contain that newly inserted course's course ID. We're going to pass that back as an output parameter, and then whoever calls our stored procedure will have to get it. They will have to retrieve it, essentially. And so here's what we're going to do. Let's go ahead and then just create this. Create procedures, CBT underscore add course. All right, there we go. And now if we come down here, we have to declare that variable to catch that output parameter. So we're going to declare a course ID, then we're going to execute our stored procedure, passing in our trainer, passing in the title, passing in the description, passing in the URL, and then we're going to select that course ID to see what it is. So we should get a brand new course ID by doing this, and there it is. Course ID number 320. And now we can execute our previous stored procedure with just the title inside of it, and we should get that course back. There it is. Cool, right? So that's how we can do good stored procedure design, designed for a data access layer, how we can use input parameters, output parameters, and force recompilation to avoid the parameter sniffing problem when we create a stored procedure that has a lot of different ways that it can be called. Oh, let me show you the encrypted stored procedure. If we head into databases, Nugget Demo DB, programmability, stored procedures, there it is. Notice the little lock on it? Make sure you save your source somewhere because there's no way you're getting at it through Management Studio. If you right click, you can even see that the modify menu is grayed out. Moving on, let's say that we wanted to create a stored procedure that accessed resources outside of SQL Server, maybe the file system or a network resource or any kind of resource. Usually it's going to be a lot easier to do if you have a little bit of programming skills and write it up in your favorite programming language. Well, what we're going to do is just that. Let's say that we wanted to create a stored procedure that scanned all of the hard drives to get information. Essentially, we're going to do the same thing that we did in a previous nugget when we wrote automation scripts and we created our own disk space checker off the extended stored procedure. We're just going to rewrite that extended stored procedure on our own and make it our own in .NET. So, first things first, let's head into C# here, Visual C# 2010 Express, where we have a project named SQL CLR underscore stored procedures. We have one class in here, and the trick to making these CLR stored procedures is to make sure that you reference the Microsoft.SQL Server.server namespace that'll give us access to everything SQL Server. And then you can create these methods here, these classes, that are tagged with the SQL procedure attribute. So we're just going to call this one getDrivesInfo, and that's how we are going to reference it then in SQL Server. And then we can use just really easy .NET code here to make this work. So the drive info object, really easy. We can call driveinfo.getDrives. That'll give us a collection here of drive info objects. And then we are just going to use that to create a SQL data record. So we first set up a SQL data record object here. We set up a couple of properties in here, one for drive, one for megabytes, and then we're just going to pipe this all out to the SQL context. So we're going to loop through the drives, and we're just going to set the output data inside of the SQL context equal to the name and the available free space. And we could do a lot more. If we wanted to grab anything there was to know about this drive, it's all inside of this drive object. So we could do a di dot and look at all this stuff. We can get the format, the drive type, all kinds of stuff we could get in here if we wanted to, and pass that back to SQL Server. We're just going to do the same thing the extended stored procedure is, and that is get the name of the drive and the available free space, piped it out to SQL context, and that's it. We created a very simple CLR stored procedure. So we can build this assembly then. That'll create the DLL, which I've already copied into our root directory. Here it is, SQL CLR underscore stored procedures .dll. And with that in hand, we can head back into SQL Server and start registering it. Now, the first thing we need to do, though, is set our trustworthy property on our database to on. And we're essentially forcing our database to trust everything within the database, meaning that we're going to write code here that's going outside of the database. Now, you should be careful with this option because there is some holes that could take place, some security holes. Somebody with extremely good SQL knowledge could actually give themselves sysadmin access if they know what they're doing through this option. So that's why you want to be very careful with this. But we're going to need to do this if we're going to access resources outside of SQL Server. So we're going to set trustworthy on at the Nugget Demo DB level. Let's switch databases then Nugget Demo DB. And then we're going to create an assembly called File System SPs from our assembly that we just created. So we're linking right to that DLL with permissions set unsafe. Unsafe is going to give this assembly unrestricted access outside of SQL Server, meaning we can access the file system, we can access virtually anything we want to. So let's execute that. That's going to bring in and create our assembly. So now you can actually see this here inside of assemblies. If we refresh this, there it is, file system SPs. Now we can create our own stored procedure off of that assembly. So here's how you reference it. You reference it going namespace, class name, the name of the method that you made. And ours is called getDrivesInfo. So we're going to create this procedure based on the class inside of that assembly. That should do it. And now we can execute our stored procedure just like we would any other stored procedure inside of SQL. It's going to call that assembly. That assembly is going to do its thing. Go get all the drives here inside of our system. Give us the drive name and the megabytes free. And there it is. How cool is that? We built a stored procedure in C#. And a good way to design these is to build it like you would normally for an application. So build it without all the SQL stuff, and then add the SQL stuff in to make it SQL aware. And that's just a matter of tagging our methods here with SQL procedure, and then making sure we pipe any information that we want SQL to be aware of and to retrieve through the SQL context object. Great stuff. All right, let's move on to our last piece here, which is working with table valued parameters. So a table value parameter is just a parameter that acts as a table. Really, that's about it. And they're useful for if you want to pass entire sets of data into your stored procedures. Now, the hitch here, there's a couple of them, is one, we need to create our user-defined table type first. So if you want to pass tables to your stored procedures, you have to create the type that is of table, define it ahead of time first. And that's what we're doing here. We're going to create a user-defined table type called trainer info as a table. That's just going to contain all the trainer info that we would want to work with. And this is just pretty much our trainer profile stored procedures that we've made very first here in our demo. We're just going to expand upon it a little bit by accepting some trainer data ahead of time. So let's go ahead and just switch databases here, and let's create this type. And now you can see this over here as well down in types. Remember, we worked in the past with creating our own user-defined data types and our own user-defined alias types. Well, now we can create our own user-defined table type. There it is, along with all the columns. You can index them, constraints. You can do everything you would normally do with a table. It's a table as a type. It's about all there is to it. So now, since we made a physical table type, we can use it inside of our stored procedures. The only catch here is that they are read-only. So we're not going to be able to modify these tables inside of our stored procedure. They're purely there for reference. We can work with the data inside of them. So here we're creating a new stored procedure called CBT underscore get trainer info that's going to accept that parameter as a table value type along with another parameter, trainer ID, and then we're just going to use that as our source for our table. And really, it's not much else to it, but let me just go ahead and create this stored procedure. And now if we want to use it, all the work is on whoever is going to call the stored procedure because they have to pass us that table full of data. So here we're going to declare a variable of that table type. Then we're going to load it up with some data from our trainer table, and then we're going to execute the stored procedure passing in that data. So let's do it. Same results. we get the trainer ID, name, expertise, and then their image. So that's one of the objectives for 464. So that's why I wanted to go through that. But just know the few things to know about them is that a table data type we can pass in as a parameter to stored procedures, but they are marked as read-only, and we have to create these as user-defined table types. In this CBT Nugget, we learned how to design and implement stored procedures. We started off with an overview where we just got familiar with what stored procedures are, the benefits and types of stored procedures out there, along with some guidelines to think about when designing them. We jumped into the virtual Nugget Lab. We saw how to create a simple stored procedure. Then we took it up a notch and saw how to create a stored procedure for data access the right way, creating a single stored procedure that we could use many different ways. We also saw how to get around the parameter sniffing problem, and that is just reusing query plans that we wouldn't necessarily want reused because it could hurt performance. And we saw how to recompile at the statement level to avoid that, so it would make a new query plan every time our query was called, every time our stored procedure was called. Then we saw how to make a CLR stored procedure, fired up .NET, saw how to create a class, and then register and use that stored procedure within SQL Server by making our own user-defined stored procedure on top of it. And at the end here, we went through table value parameters and how they work with stored procedures. I hope this has been informative for you, and I'd like to thank you for viewing.